We did it. It was the weight says FG over M.
F net equals MA.
Oh, so it'd be 500 divided by 1,000
equals F net over M. So yeah, so 500 newtons divided by 1,000 kilograms gives you an acceleration of 0.5 meter per second squared. So the net force is 500 newtons, 1,000 minus 500, and the mass of the vehicle is 1,000 newtons from our weight. Cool? Give me a thumbs up if you're with me so far. Wave your hand around if you need me to talk about it again. Can you do it again, Mr. Pye? No? No? Okay. Terminal velocity. All right. So this is what you guys wanted to talk about, terminal velocity. So it works like this. You jump out of the plane, and the moment you jump out of the plane, you jump out horizontally, what is your acceleration? Negative, yeah, negative 10 meters per second. So the moment you jump out of a plane, woo, it's negative 10 meters per second. But your velocity is what? In the vertical direction. We don't know about the plane, but in the vertical direction. It's zero, yeah. Your velocity is zero because at that point you're basically just going to be in free fall. So you jump out of a plane, your acceleration is negative 10 meters per second, your velocity is zero. 1 second after you fall, or after you've been falling, now your velocity is
9.8.
negative 10 meters per second, right? So let's just 9.8 out the window. If you go to college and you get a physics professor who wants to use 9.8, use 9.8. Until then, use 10. So you jump out, you have an acceleration of negative 10, your velocity starts at 0, 1 second later it's negative 10, 2 seconds later it's negative 20, 3 seconds later it's
negative 30,
negative 30, and negative 40, and negative 50. So you're basically just a rock, right? But here's the crazy thing. As you speed up, you encounter a force of friction. And FF air varies with the square of velocity. Varies with the square of velocity. We're not going to go into all the calculus required to know what air resistance is, but I will tell you, for posterity, might come up in Jeopardy someday, that air resistance varies with the square of velocity. In other words, when you go twice as fast, you encounter 4 times the air resistance.
Oh.
That's what that means. So you will never be tested on this in this class. But just for posterity, that's what it is. There's a lot of other things. Texture and aerodynamic cross-section, how big of a hole you make in the air matters, and the texture of your vehicle matters.
It's like surface area too. Like, so say like when you're skydiving, you go like on your belly.
Make a big hole. Yeah, you want to make a big hole in the
You
air.
have more air resistance, but if you go like into like a more of a dive position,
You have
can
less.
go faster.
And if you have floppy clothes, that'll create a lot of friction too.
Okay.
So
There's a lot of variables that we're not going to focus on.
for texture, is that like whether it's like smooth or like dimpled, like all is that?
Although dimples actually reduce air resistance.
I know.
Yeah.
They like.
So you probably want to like hold.
I've often wondered, like, if I ever get an old car, I'm going to dimple the whole car like they did in Mythbusters. They did it with clay. I'm going to do it with a hammer, dimple, 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 or some sort of power tool, and see if it gets better gas.
My friend covered his car in like bed liner, and I was like, oh.
You mean line yeah.
You mean hardened polyurethane?
Probably.
Okay, so you jump out of a plane. Your weight is mg, mass times gravity, and when you jump out of a plane, the weight is the only thing that's creating any kind of acceleration. So we know that weight equals mg, and then the acceleration is fg over m, which might seem like, why would you bother writing that? But this is what's causing you to pull down, this is what's causing acceleration. Because the F net is only mg. So the F net is only fg. Okay. And as you fall, your air resistance starts to build up, and build up, and build up, and build up. And eventually, you get to a point where the drag is equal to your weight. Because drag is going to constantly getting bigger and bigger and bigger and bigger, and eventually it's going to equal your weight. Much like when I was pushing on this cabinet, the force of friction gets bigger and bigger and bigger. There is an upper limit. It's going to get bigger and bigger and bigger, but there is an upper limit. For aerodynamic drag, the upper limit is what? So eventually your F net is going to be Fg minus Ff. And when it gets to 0, you are in balance. When those two things are equal to each other, you are in equilibrium. The downward weight is equal to the upward net force, and you're in equilibrium, so your acceleration becomes 0.
That's terminal. How long does
That's
it,
terminal velocity.
how long does it usually take to hit terminal velocity?
A few seconds.
Okay, dang.
Not long at all.
That was like, what, that's like...
So I asked you again, what is the upper limit of air resistance of a falling body? Exactly, which is what? Not 10 meters per second. You cannot express it in a number, you have to give me a variable.
Oh.
What is the upper limit of FF air? That's for two surfaces in contact with each other.
Well, that's, yeah. It's
Well, let me ask you this. Can air resistance ever push you back up? But when you see the parachuters and there's a cameraman and then they pull the chute, what do they do? Where do they go? They go up, right?
Yeah.
No, the cameraman keeps going down. If you pull the,
Slower.
yeah, exactly. So what happens is two objects falling next to each other. The cameraman keeps going down because he doesn't know when the guy's going to pull the chute. So when the guy pulls the chute, he started going slower. The cameraman's still going faster. So when somebody pulls a chute on TV, they don't suddenly go up. It's just the cameraman still going down at terminal velocity.
Yeah, he's just not going down stuff.
So what is the maximum value of air resistance? Can the FF ever be bigger than the FG? No. So what's the maximum value of FF? FG. The maximum value of the force of air resistance is the weight. So again, if you don't get anything from that, just remember that when someone pulls the air chute, they don't go up. They just suddenly go slower than the cameraman. Okay. Anyway, so yeah, so force of air resistance can be as big as G, but no larger. So now you're cruising along, woo! You're like, 8,000 feet. You're cruising, woo! You're like, my weight is equal to my drag, woo! Have some fun. And then the coach says, you should probably pull your chute because I don't want the headlines of someone dying on my watch. So you go, okay. So you pull the chute, woof. Force of friction. What happens to the force of friction?
There he goes up.
It goes up, and now that you pulled the chute, now you have a new FF. Now you have a new FF. I'm going to call it FF sub air sub chute. Chute. Right chute. Parachute. Sub chute. And now it's much bigger than FG. So what happens to you? You suddenly go up.
Go down less slowly.
You go down less slowly. So now you have a situation where your upward resistance is now bigger than your downward weight. And if your upward resistance is now bigger than your downward weight, there is a net force in what direction? Up. And if there's a net force in the up direction, what is also in the up direction? Acceleration. So now you have an acceleration. So your velocity starts at 0, and it goes negative, 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 terminal velocity. And then your velocity goes slower because your acceleration acts on it. And we can graph this, and it's a really cool graph.
Acceleration never goes positive.
Before I show you the graph, what do you think, let's make a little sketch. What do you think the graph of velocity would look like over time? So let's make a little graph, and we're going to graph velocity over time, and I'll get you started. So this is where we jump, and this is going to be vertical velocity, and it's going to be inverted. I'm going to put negative v. It's going to be upside down, so we can, okay? And it's going to go like this. We get faster and faster and faster. Okay, you finish the graph. This is negative v, this is jumping, velocity is getting faster and faster. And by the way, the slope here is negative 10 meters per second.
And then like
I need more space, so.
eventually plateau out because
So write it down, yeah, scribble it. Scribble your graph, yes, it
No,
will
when it
eventually
hits
plateau
terminal,
out.
it'll plateau. Oh yeah. And then afterwards, it'll, yeah.
booster virus is distilling apple juice alcohol.
That would be fun. Make apple cider. You know, really fun fact. Up until 100 years ago, people would think you're weird by eating apples because apples weren't used for like food. They were used for making cider, hard cider. Freaking weirdos.
They're missing out.
I don't know how they kept the doctors away then.
Some days are gonna be like 100 years from now. You're like your grandkids are gonna be like, you are 80 years old. You actually ate those? Gross. You're gonna be like that same kind of thing.
Oh, dude, I ate this.
Have you finished your scribbles? So make your graph. Somebody poke Scott so he can make his graph. So make your graph. If you don't have any paper, just write on the desk. Someone will scribble it away eventually. What's the graph gonna look like?
Oh,
but it's not
It's negative
acceleration,
heat.
it's
Yeah,
time.
it's gonna make it. If you're more comfortable, you can make it go that way, but I just think it's overall speed. Okay. So yeah, as eventually it's gonna start getting slower and slower and then plateau out. So here we have terminal velocity.
And then it'll go back down. Right?
Yeah. So then we pull the chute.
But it won't cross zero, right?
Correct.
It can't go up.
So we pull the chute. I think it actually is UTE. We pull the chute, and it's how? We pull the chute. There we go.
I mean, I can see, like,
We pull the chute, and what's the velocity going to do? It's going to go down again. But then
It won't go back up either.
it won't go down to zero. It won't go back up. But what's going to happen to the velocity at this? It's going to go down to zero?
It will never get to zero.
No,
It'll keep
but it
getting
will
smaller.
go down to a new terminal velocity. This is terminal velocity with chute. Okay, so it's going to go up, 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 up. It's going to plateau out. Then you pull your chute, and you're going to start slowing down. Then you're going to get to a new terminal velocity with chute. Does that idea make sense? Okay. Okay. If you have questions, wave your hand around. If you want to move on, give me a thumbs up. All right, there we go. So this is kind of a fun animation.
Oh, he's that thick boy.
Yeah, his name is Bronco, by the way. And I know his name is Bronco because he's on your worksheet you're getting.
Mom's Bronco.
Bronco.
That's me.
Rondo's got what plants great.
What's that?
Electrolytes. But Bronco's got electrolytes. Bronco's got what plants crave.
Why
You guys
do
haven't
plants-
seen. You guys haven't seen
Why do,
Idiocracy because it's
why do
R-rated.
plants
so
want
we're going to-
electrolytes? I don't know, because it's what
I know
Brandon
you haven't
has.
seen it because it's R-rated. It's backwards, yes.
It has electrolytes.
Okay, so good question in the back.
The only source of water is
Guys?
toilets.
Charles asked a question. If there's a negative acceleration, that means he's going up. It doesn't mean he's going up. It does mean he is slowing down. Remember, when velocity and acceleration are the same sign, you're speeding up. Speeding up. When they're opposite, you're slowing down. So if your velocity is down and your acceleration is also down, as when you jump off the plane, then you are speeding up, speeding up, speeding up. You pull the chute, now your acceleration is up and your velocity is down, and you're slowing down, slowing down, slowing down.
And then the velocity goes
Until the velocity goes, okay, until it becomes terminal velocity. Acceleration becomes zero eventually. So when you're at terminal velocity, you have an acceleration of zero. So his acceleration is negative 10, it's constantly negative 10, it gets faster, now drag kicks in, his acceleration starts slowing down, he pulls his chute, and now acceleration is yeah. Does that make sense?
Well, acceleration does become positive %.
From everywhere until you pull your chute. So yeah, so ignoring the negative E. So your acceleration is down when you jump out. When you pull your chute, your acceleration becomes positive, and it stays positive until it becomes zero at the new terminal velocity. So when you jump out, in summary, we have like 10 minutes left. You jump out. Your velocity is negative and your acceleration is negative 10. As air resistance acts on you, your acceleration becomes negative 10, negative 9, negative 8, negative 6, negative 4, negative 2, 0. When it has become 0, that's the case when your air resistance equals your gravity. Does that idea make sense? Okay. Then you pull your chute, whoosh! And now your acceleration is positive something. We'll just say positive 20. It's pretty radical. Positive 20. And you're slowing down. Because your velocity is down, your acceleration is up, you're slowing down. And your acceleration is, this force drag vector is really big, but it's constantly getting smaller as you slow down. Does that make sense? It's going to slow until once again, that drag vector is once again equal to your weight. And you're at a new terminal velocity. So your acceleration would be positive 20, positive 15, positive 10, positive 5, 0, and now you're at a new terminal velocity in your parachute. Hope I don't get pooped on by a bird. Hope I don't land on my car.
Just in this side.
This is what it looks like if you actually take into account all the crazy curves. You can kind of see how our graph is kind of like that graph, but this one takes into account the squared relationship of air resistance. Pull the chute, whoosh. There's questions on this on the mid-unit test and the mid-unit quiz. All right, how are we doing so far? Because once we're done with this, we're going to change gears, and I'm not going to be able to show you this probably today, or not today, but I'll show you soon. There's a really cool thing that I need to show you, and it's dealing with inclined planes. Okay, so today, and tomorrow's lab, and Thursday and Friday's labs, we'll be dealing with forces in a single dimension. Okay? Tomorrow. That is due tomorrow. Okay. Questions? Okay, so we'll talk about inclined planes next week, and I'll show you this really cool demo. And you can work on your worksheet until the end of class.